Welcome. The topic we'll be discussing in this lecture is converting an infix expression to an postfix expression. Okay, that is basically we'll be discussing like how to write a program to convert an infix expression to an postfix expression. So in the last class we have discussed like given a postfix expression, how a compiler will evaluate the postfix expression correctly using stack. That's what we have discussed. Okay. So in this lecture we'll be discussing like given an infix expression how it can be converted to a postfix expression using a program and what is the intuition or the logic behind that. Okay. So this also for converting an infix expression to a postfix expression also we'll be using stack. So all these are nothing but applications of stack. So now we have many applications of stack. One is during function call and return, during recursive function stack will be used, and for evaluating a postfix expression stack will be used, and for converting infix expression to a postfix expression also stack will be used. Okay, fine. So manually how will we convert infix expression, that we have already discussed. When an expression is given you have to parenthesize that expression, that is depending on the precedence and associativity add the parenthesis. So this is the original expression. If you add parenthesis it will become like this. Okay. Sometimes expression may have some parenthesis but you have to fully parenthesis. Okay, we have to make it fully parenthesized, right? And after making it fully parenthesized, what should we do? To go for the innermost parenthesis and identify the operator, and that operator will replace the nearest closing parenthesis. Okay, and do this repeatedly for the next innermost bracket and go on until all brackets were covered. Okay, so this is the process, and then delete all the parentheses. If any left parenthesis, open parentheses are left out, delete that. Okay, so then you will get an uh, the respective postfix expression. This is how we do manually. Okay, but we can write the same thing as a program also. That is, you have to identify what is the precedence, and then you have to include the bracket, and then the operator should replace the bracket. Okay, but the program will become complex, and also not only complex, it will involve two pauses. It cannot be done in a single pause. It needs at least two pauses. That is, one pause is used to parenthesize. You have to parenthesize the entire instruction during one pause, and during another pause you have to replace the all the operators should replace the respective closing parenthesis. Okay, so basically this may not be an effective technique for solving this expression using a program. Okay, from human point of view this is fine. That is, when you do with pen and paper you can follow this approach for converting infix to a postfix. But this may not be the right approach for writing a program to convert an infix to postfix expression. Okay, so then how we are going to do, how we are, so before discussing the example, let me share the logic. So we are going to use some other logic which will quite comfortably convert an infix expression to a postfix expression. Okay. So these are the steps involved in the uh, logic or the algorithm. Okay, what it says. So we have an infix string, we have an infix expression or a string, whatever it may be. So given an infix expression, from the infix expression we have to read character by character, or we have to read token by token. Read the first token from the infix string. Okay, then check whether the token is an operand or not. Read the first token from the infix string or expression and check whether the first token is an operand or not. If it is an operand, just display it to the console. Console means monitor, standard output device. If it is operand, just display it to the console. Okay, so this is the first part. Suppose if it is not an operand, if it is a close bracket, if the red token is a close bracket, then we maintain a stack. We'll have a stack. Okay. If it is a close bracket, then what you have to do is you pop the topmost element of the, you first check before popping, first check what is the topmost element of the uh, uh, sorry, you need not check, you just pop the topmost element of the stack and display it on the console. Okay, and do this repeatedly, keep popping and displaying, keep popping and displaying until you reach a close bracket in the stack. Okay, so the second step is, if the token that we are reading is a close bracket, then what we should do in the sense, repeatedly pop the elements from the stack and put it in the console. But before displaying it in the console, check what is that, whether is it a close bracket or not. If it is, until it is not a close bracket, you keep displaying it in the console. Okay, if it is a close bracket, then discard that close bracket and stop. That's it. If it is a close bracket, then discard that close. This close bracket should not be displayed. Okay, and no more, we need not pop, and stop popping also. Right, I think this second step is clear. That is, if the red token is a close bracket, if the red token is a close bracket, then pop the element continuously from the stack and display it in the console until you reach the open bracket. Okay, until you reach the open bracket from the pop or from the stack. Okay, so if open bracket is reached, then you just discard that open bracket and also stop popping. If the red token is not an operand and not in close bracket, then what we should do? Then it means, if it is not an operand and if it is not a close bracket, means it is some operator. Okay, it may be either plus or minus or star or whatever it may be. Okay, so what we should do in the sense, we have to check what is the precedence of the element which is at the top of the stack. Okay, identify the precedence of the element that is at the top of the stack and compare that with the precedence of the this incoming token, whatever the incoming token, it may be either plus, minus or star or whatever it may be. Okay, the precedence level of the token that is in the top of the stack should be compared with the precedence level of the incoming token. Okay, if the precedence level of the top of the stack's element is greater than or equal to the precedence level of the incoming token, then pop that element and display it. Then pop that element and display it. Keep doing this repeatedly. That is until the top of the element stacks precedent, until the element at the top of the stacks precedence is greater than the this particular incoming uh, tokens precedence, you keep popping and displaying that element from the top of the stack. Okay, the moment you find that the top of the stack element is having a lesser precedence than the element at the than the incoming element, then don't pop. Okay, this checking we should do before popping. Okay, this checking we should do before popping. Only if the precedence is only if the precedence of the element at the top of the stack is greater than or equal to the precedence of the incoming token, we will pop and display. If it is less than, then we won't we won't pop. It will come out of the control, will come out of the while loop. Okay, and then whatever the token, whatever the current token we have, just push it into the stack, push that token into the stack. Okay, again go to step 1. What is step 1? Now read the next token and do this. So like this step should be repeated for all tokens. Okay, if the infix string contains 10 tokens, then it will repeat for 10 times. Okay, after repeating it for all the 10 times, then come out. Okay, then you check, is there anything in the stack or not. If there is something in the stack, pop the element from the stack and display it on the console. Okay, so this is the logic. This is the logic So here ISP represents in stack precedence. Okay, the element at the top of the stack, that element's precedence. ICP means incoming precedence. What is the precedence of the incoming element? Okay, so to summarize the logic, read token by token, check if the token is operand. If it is operand, display. If it is a close bracket, then if the token is a close bracket, then keep popping elements from the stack and displaying it in the console until you reach a open bracket. The moment you reach the open bracket, discard that open bracket. Don't display it in the console. Okay. If it is not an operand and if it is not a close bracket, then it is an operator. Then what you have to do is check what is the precedence level of the element at the top of the stack and compare that with the precedence level of the incoming token. If the precedence level of the element at the top of the stack is greater than or equal to the precedence level of the incoming element, then pop the top of the stack element and display it. Keep doing it repeatedly. So this should be continuously done until the precedence of the top of the stack element is less than the precedence of the incoming token. Okay. So when the precedence of the top of the stack element is less than the precedence of the incoming token, then you come out of the loop, and whatever the token is there, just push that token into the stack. So repeatedly do this until you reach the end of the particular infix string. Okay. After processing all the tokens in the string, then check is there anything in the stack or not. If something in the stack, then pop the token from the stack and keep displaying it. So display pop all elements from the stack and display it. Okay. So this is yes stack and display it. Okay. So this is the logic. Okay. So here what we are doing, this is just a repetition. This step is the crucial thing. Okay. If it is operand, we just display. If it is a close bracket, pop and display until you reach open bracket. Okay. And the last step is we have to compare the precedence of the top of the stack element with the precedence of the incoming token. Okay. So in that case, these are the rules we are applying. Operators are taken out of the stack as long as their in stack precedence is higher than or equal to the incoming precedence. Okay. Operators are taken out of the stack as long as their in stack precedence is higher than or equal to the incoming precedence of the new operator. Okay. Or the new token, whatever it may be. Okay. And there is another important thing which we should understand. So for this algorithm to work, we have one small catch here. Okay. This open bracket will behave in different way in different context. This open bracket will behave in different way in different context. Okay. This open bracket, it will have a low in stack precedence. When it is in the stack, this open bracket will have a low precedence level. Okay. And it will have a high precedence level if it is a incoming token. Are you getting? So this way the algorithm should adopt. Okay. That is, if the open bracket is in the stack, then it will have the low precedence level, or you can say lowest precedence level. Okay. But if the open bracket is coming as a part of the incoming string, if it is a recently read token, then it will have the high precedence. Okay. Fine. So we need to check two types of precedence. One is in stack precedence and another one is incoming precedence. So we maintain two arrays which will store the precedence level of different operators. Okay. So as we already discussed, in stack, this open bracket will have the least precedence. Okay. So when it is in stack precedence, so in stack precedence of open bracket is 0. Okay. Whereas in stack precedence of close bracket is 19. It is quite higher value. Why? Because in the logic you see, whenever there is a close bracket, we have to pop everything until you reach an open bracket. Okay. So some higher number is given, right? And then the precedence of plus and minus are same, some same precedence, some same number. Okay. That number you have to give. So here 12 is given, right? and the precedence of star, slash and percentage modulo is also same. So these three also should have the same number. At the same time, these three should have the higher number than plus and minus. Okay, you can give any other number also, but this number should be higher than uh, plus and these numbers for precedence level for star, slash and percentage should be higher than plus and minus. Okay, so this first row, it corresponds to in stack precedence. Okay, and the in stack precedence for UOS is 0, end of stack, that is backslash null character is 0, right? And but when the open bracket, when it is coming as a incoming open bracket, that will have the highest precedence, that is 20. Okay, remaining all, there is no change, it is both incoming precedence and in stack precedence are same. The incoming precedence for close bracket is also 19. Okay, the incoming precedence for plus is 12, minus is 12, star is 13, slash is 13 and modulo is 13. Okay, so this precedence number is for our understanding we are giving. Okay, it is not the precedence table that is given by C programming. Okay, but obviously that we should follow in the sense that star, slash and modulo should have higher priority than plus and minus. Okay, but this numbering we are giving for our convenient. Okay, and why we are treating this open bracket with two precedents for incoming stack and for in stack and for incoming, the reason is you just recall that logic. Whenever there is an operator, you have to keep popping from the stack. Okay, and you have to check whether the precedence of the top of the stack element in stack is greater than the incoming element, greater than or equal to, then pop and display that element. So keep doing this as long as the precedence of the in stack element is greater than or equal to the precedence of the incoming element. Okay, fine. So, and finally, once you, the moment you found an element whose in stack precedence is less than the uh, precedence of the incoming element, then we push the incoming element into the stack. Okay, that's the logic. Okay, now assume that incoming element is close bracket. Okay, if incoming element is a close bracket, then what you are supposed to do? We just need to push that into the stack, nothing else. We need not do anything, because close bracket means some expression is starting there. Sorry, open bracket. If the incoming token is a open bracket means some expression may be starting there, a plus b. Okay, it may be a sub open bracket, but still something is going to come, c star d. Okay, so now there is no meaning in popping. Now we won't pop, we have to only push. Okay, that is in incoming, if you encounter an open bracket, you have to just push. That is the reason we are giving it the highest priority or highest precedence. So you see 20, no other operator was given that precedence. So it is 20. It means what? It means what? It means what in the sense, uh, now even if you pop something from the stack, even if you pop something from the stack and check whether that element's precedence level is greater than this precedence or not, it won't be greater. Obviously it won't be greater, so this will be pushed. Okay, so whenever there is an incoming, you need not check, you can directly push. So that we are giving this as 20, the highest number. I think you are understanding. So if it is an operand, we will display. If it is a closed bracket, we will keep popping it and we will display until you reach a open bracket. Okay, if it is any other operator means here not only plus, minus, star and slash, open bracket also an operator. Okay, open bracket is also an operator. So when an open bracket comes, what you should do? You should just push. You should just push. Okay, so what this logic says, incoming elements precedence should be greater than the, what you call, uh, in stack elements precedence should be greater than the precedence of the incoming element. If that is the case, if greater than or equal to the incoming element's precedence, that is the case, you keep popping it and display, right? But when, if the incoming element is a open bracket, we just want to push. Okay, we just want to push. then it means that we want this condition to fail. We want this condition to fail. That is, for any in stack element, that element's precedence should not be greater than open bracket. You're getting? For any in stacks top of the stack element, its precedence should not be greater than open bracket, because the moment you encounter an open bracket in the input string or in the incoming token, we want to just push. Then how can we do that? Then you have to give a higher precedence for that, so that we are giving the highest precedence. Okay. Now, now anything, even if it is star, if it is, that is the top of the stack, its value may be 13 or 14, so it is less than, so this condition fails, so we just pop this to the stack. Okay, so that is the reason why here we given a high priority value for open bracket when it is encountering as an incoming token. Okay, right, fine. But when it is encountering as an outcoming token, we are giving the lower priority. Okay, uh, because because if it is uh, uh, because when we want to remove the open bracket, from the stack, only when you encounter the close bracket. So you getting, again, see this logic. When you encounter a close bracket, what you should do, keep popping until you reach the open bracket. Keep popping until you reach the open bracket, right? Okay, assume that you encounter a plus. Say that the top of the stack is star. Say that the top of the stack is star. Now you compare the precedence of star and plus. Star is greater than plus, so you will move out. Okay. Say the next is slash. Then you compare slash precedence is greater than plus, so move slash out. Okay. Say next is a open bracket. But do you want to move this open bracket out? No. Open bracket should be moved only when the incoming is a close bracket. Okay. Then what should be its precedence? So now when the plus is the incoming operator, right? And if the in stack thing is open bracket, we don't want to move it out. If you don't want to move it out, then when the open bracket is inside the stack, you should give the least value. Are you getting? You should give the least value. So the least value is 0, right? So so that is the reason when the open bracket is in the stack, it was given the least value. Okay, but when the open bracket is an incoming bracket, it is given the higher value. Okay, when the open bracket is an incoming bracket, we directly want to push into the stack. When the open bracket is a in stack, then we don't want to pop until the incoming thing is a close bracket. Okay, for any other operator, this should not be popped out. That is the reason for open bracket alone, the precedence level is different. Okay, fine. So with this understanding, now let us try to see some examples how it works. Say this is the infix expression that you want to solve. A plus B star C. Star has a higher priority than plus, that we know. Okay. So first token is A. So what is the algorithm says? If it is an operand, just display. Okay, just display. Top is -1 because nothing is pushed into the stack. Next is plus. Plus. So this is an operator. It's not an operand. It's not a closed bracket. It's an operator. But is there anything in the stack? There is nothing in the stack. Okay, as there is nothing in the, if there is nothing in the stack, let us assume uh, end of stack is there. Okay, end of stack uh, or uh, or end of string, that is null character, is there. Its precedence level is 0. Okay, so or you can say if nothing is in the stack, just push into the stack. So plus enters into the stack and top becomes 0. Okay, next token is B. B is the operand, so just display it. So after A, B will be displayed in the console. Next token is star. Okay, so when this is star, it is an operator. It is not a open, it's not a closed bracket, it's not an operand. So now what you have to do, compare the precedence of the in stack precedence. In stack precedence is plus. What is its precedence? As per our table, 12. So the precedence of plus is 12, whereas the precedence of star is 13. So this is not greater than this. Okay, then you need not pop. So whatever the incoming token, just push into the stack. So star is pushed into the stack. Okay. Next token is C. What is that C? It is an operand. So just display it. Next, there is nothing. We have reached EOS. Okay, if you have reached EOS, then what you should do, as per the algorithm, you can see after processing all the elements, what you should do is just pop all tokens from the stack and display it. So already A, B, C were displayed. Now pop. Now if you pop, star will come out. So this will display star. Then plus will come out. So this will display plus. This is not equal to, this is plus. I think there is something wrong. Okay. So it will be ABC star plus. Right. So this is how it executes. Let us take one more example. Say this. A star B plus C star D. Here there is a bracket for B plus C. Okay. Let us see how it works. So this is the input string. So the first token red is A. It is operand. Just display it. Top is -1. Next is star. Okay. Next is star. Star is coming 2 times. So first star we are calling it as star 1. Next star we are calling it as star 2 for our differentiation. Okay. So multiplication operator. So it is an operator. Currently stack is empty. As stack is empty, there is nothing to compare. So just push. It is pushed. Top becomes 0. Okay. Next is open bracket. So open bracket has the least priority. Okay. So still as per the logic, what you should do? If it is a operand, push into the stack. If it is a closed bracket, pop until you reach open bracket. Else what you should do? You have to compare the precedence of the top of the stack with this precedence. Okay. So what is the precedence of the top of the stack? Star's precedence is 13. Star's precedence is 13. What is open bracket precedence? Open bracket has two precedents. It has ISP, in-stack precedence, and incoming precedence. Now you have to check the incoming precedence. Its incoming precedence is 20. Its incoming precedence is 20. Okay. So the in-stack precedence is not greater than incoming precedence. In-stack precedence is 13, which is less than the incoming precedence. Okay. As it is less than, as the in-stack precedence is less than the incoming precedence, you need not pop. Rather, this open bracket will be pushed into the stack. Okay. And increment the stack pointer. It becomes 1. Next token is B. It's an operand. Just display it. Next token is plus. It's an operator. Again you compare. What is the precedence of plus? It is 12. Okay. What is the in stack precedence of open bracket? What is the in stack precedence of open bracket? 0. So again 0. This is 0. So in stack precedence is not greater than the incoming precedence. So you need not pop, just push. So plus is pushed into the stack. Top of the stack is incremented to 2. Next operand is C. It's operand. Just display that. So ABC appears. Next is close bracket. If it is a close bracket, what you should do? Pop until you reach open bracket. Pop until you reach open bracket and display. Okay. So pop this out. Plus will display. Okay. Right. Again. So when it is a close bracket, what you should do? You have to keep popping until you reach the open bracket. So pop plus out, plus will be displayed. Next, when you pop, it is close bracket. Close bracket has came. But you need not display that. You discard that. It should be discarded. That's it. Okay. So you have to pop until open bracket comes. But here open bracket already comes just after popping one element. So we will stop that. Right. Now these two are popped. Now the stack top is only the star is there. This one represents, this is first star. Okay. Now the next element is what? Next token is the second star is there. Okay. Now compare the incoming operator and uh, in stack operator precedence. So in stack operator precedence is 13. Incoming operators precedence is also 13. Okay. So if it is greater than or equal to, then you should pop. So pop this first star and display it. Pop this first star and display it. Okay. Now there is nothing in the stack. So just to push the second star into the stack. So the second star is pushed into the stack. Okay. And the next token is D. So D, it's a what you call, it's an operand. So just display it. So D is displayed. Now we have reached the end of string. So after reaching end of string, what you have to do? Just pop whatever in the stack and display it. What is there? The second star is there. Display that. So this is the postfix notation. ABC plus star D star. This is the postfix notation of this particular infix string. Okay. So this is how the algorithm works. Now let us see the code for that. So we have to maintain an array which stores this in stack precedence and incoming precedence. So we are what you call, we are maintaining an two arrays, int in stack precedence and int incoming precedence. So this in stack precedence contains these values 0, 19, 12, 12, 13, 13, 13, 0. And incoming precedence contains 20, 19, 12, 12, 13, 13, 13, 0. This first this precedence corresponds to left parenthesis. Okay. Next precedence corresponds to right parenthesis. Next corresponds to plus. Then for minus. Then for multiplication. Then for division. Then for modulation. Then for end of string. Okay, like this it is being stored. Okay. And I think in the last class we have discussed the enumerated data type for different different operators, L parent, left parenthesis, right parenthesis, plus minus, all these things. Okay. So that precedence is a, so that same thing we will be using here also. The same what you call enumerated data type. For that we are creating a data type precedence. Okay. Okay. And this is an array which this is a stack which can store some n number of elements of type precedence. Okay. And this is the algorithm for postfix. There is a variable symbol and there is a token of type precedence. N is initially 0, top is 0. Initially at the stack we are pushing EOS. Okay. This is for our programming convenience. We are pushing at the initially when the stack is empty. Okay, we are pushing EOS. This is which means end of string is being pushed here. Okay, end of string, that is backslash 0. End of string is nothing but backslash 0. This EOS is defined in that enum. In enum, if you recall, EOS is defined there. Okay, so where it is? Yeah, here in enum you can see all these are there. Left parenthesis, right parenthesis, plus, minus, times, divide, mod, EOS. EOS also here. Okay, so basically EOS represents the backslash 0, right? So that we will verify using this. So whenever there is a, we have used this function. Okay, whenever there is a backslash 0 we return EOS, which means end of string. Okay, so that EOS initially we are pushing into the stack, and then what we are doing, we are writing a for loop. For token equal to get token ampersand symbol comma ampersand n. Okay, so this get token is the same function that we have previously discussed for evaluating and postfix expression. So this get token, it takes one address of a character and an address of an integer. Okay, and it will, whatever the expression, it will read character by character and it will check what is the token it is, and accordingly it will return whether it is a left parenthesis or right parenthesis or plus or minus, or if nothing, if it is not an operator, then it will return that it is an operand. Okay, so that same thing here we are using. So here we are using it in a for loop. For token equal to get token, we are reading the token, and this is the terminating condition. How long you should, this for loop will repeat in the sense until the token is not equal to UOS. Okay, then this is incrementing or reading the next token. Actually this both are same. Again in the next iteration read the next token, token equal to get token ampersand symbol ampersand n. Okay. After reading, check whether the token is an operand or not. If the token is an operand, just display the symbol, printf percentage c symbol. Okay. If token is not an operand, if it is a right parenthesis, then what you should do, until until the top of the stack is not equal to left parenthesis, okay, you pop the element and display it. Okay, pop the element and display it. Okay, and when the moment you encounter the uh, I mean left parenthesis or the open parenthesis, pop that and discard that. Okay, discard the left parenthesis. Okay, else if it is operator, then what you should do, as long as the ISP, that is the in stack precedence of the stack top element. Okay, as long as the in stack precedence of the stack top element is greater than or equal to the incoming precedence of the token, what you should do is you just pop the stack element and display it. Okay, pop the stack element and display it. The moment the in stack precedence becomes lesser than the in stack elements precedence becomes lesser than the incoming tokens precedence, just push the incoming token into the stack. Just push the incoming token into the stack. Okay, so do this operation for all the tokens. Do this operation for all the tokens. Okay, once all the tokens were done, then finally what you should do is you check is there anything in the top of the stack or not, if the stack is empty or not. As long as stack is not empty, as long as stack is not equal to UOS, keep popping and display it in the console. Okay, as a result what you will get is a postfix expression. Fine, this is the overall logic. Let me show you the code of this, which I have written. Where it is. Let me stop this. Closed WSL. You open WSL. This opening. Okay. CD backslash ls infx star.c. Yeah, this is the file name. So nano infix to postfix. Okay, infix to postfix.c. So you can see here, this is the complete code. We are using stdio.h, stdlib.h and string.h. We should use a stack. So this max is set to 100 and we are creating a stack of character, because here we are not going to do any addition or subtraction or anything. We are going to just convert the infix to postfix. Okay, so this is a stack of size 100. It's a character array of characters. Okay, then TOS top of stack, I'm using this as a pointer, or you can call it a stop if you don't like TOS term. So int TOS is initialized to -1, which means stack is initially empty, and this is the pointer to a character. We are going to use this to store the input string. Okay, so this typed of enum, which is of precedence, which is same as that of what we discussed in the previous program for evaluating and what you call the postfix expression. The same enumerated data type here also we are using, and this is the precedence for in stack precedence. Okay, and this is the precedence of incoming tokens precedence. Okay, so the first element precedence corresponds to left parenthesis. The second element precedence corresponds to right parenthesis. The third precedence value corresponds to plus. Fourth for minus, then times, so on and so forth. Okay, fine. So we are going to use a function called get token which will take a character as a input, and it will return the precedence. What is the precedence of that? Okay, it will take the character and say whether it is a precedence means it is any one of this. Okay, so it will just take a character and will say whether it is left parenthesis or right parenthesis or plus or minus or times means multiplication or divide or modulo or uos or operand. Okay, for example, if the character is, if the input here, if the character input is, say if it is left parenthesis, then it will return, sorry, if it is left parenthesis then it will return l parent. Okay, l parent. Okay, if it is right parenthesis then it will return right parent. Okay, if it is star then it will return times. Okay, if it is uh, if it is modulo then it will return mod. Okay, this is what this function is supposed to do. If it is a then it will return it is an operand. If it is b it will return it is an operand. If it is 1 it will say it is an operand. Are you getting? So what is that? What is each token? We should identify what is that. So for that, whether it is, so each token will be any one of this, either left parent or right parents or plus or minus or times or divide or modulo or EOS or operand. Okay, to identify that we are using this function. Okay, so this is for pushing a character into a stack. This is for popping a character out of the stack. So if whenever the stack is empty, we are closing the program. Okay, we are not further continuing. It will come out, right? Exit we are using, right? And this is the main function. Here we are declaring some variables. Initially n is set to 0. There is a variable n1, I for loop variable, two characters, symbol and ch. Token is a variable of type precedence. That is, token precedence is what? This is our user defined data type. So that means token can take any one of these values. Either it can be L parent or OR parent plus minus or whatever it may be. Okay. So these also have some integer numbers. L parent is 0, OR parent is 1, plus is 2, minus is 3, 4, divide is 5, this is 6, UOS is 7 and operand is 8. Okay. So token is a variable of type precedence, right? And TOS, which is initially set to -1, we are incrementing, that becomes 0. Then at the top of the stack, okay, at the stack top, we are writing UOS, but I think here we cannot write directly UOS because our stack is what type? Stack type is a character type. Okay, UOS is what type? UOS is of type precedence. Okay, UOS is of type precedence. Okay, that is a different data type. It's a user defined data type. So you cannot let us not write UOS. Rather directly we can say \0. UOS is nothing but what? \0. \0 only we are calling as UOS. End of string. End of string. Okay, null string. So initially we are pushing a null string to the stack. Then we already declared a character pointer, that is expr. So that is, for that we are allocating some dynamic memory because we want to store the input. expr is equal to character star malloc 10 into size of character. So we are allocating space for holding 10 characters, and that starting address will be available in the pointer expr. Okay. Instead you can also use character array, whatever you feel convenient. Okay, for the sake of using pointer here I am using, we are asking the user to enter the infix string. Okay, whichever the infix string that is to be converted to postfix, enter that string. Like that we are asking, enter the infix string which is to be converted to what you call postfix. So that we are asking, the user will enter the string that will be stored in this memory location, and that location will be pointed by expr. Okay, now we are checking the length of the string, length of the infix string, what is the length, and that is stored in n1. Okay, now we have to take character by character. So we are running this for loop. For I is equal to 0, I less than n1, I plus plus, right? We take the first character or the first token from the infix string, and it is stored in the variable symbol. Symbol is a variable of type character. Okay, then what is that we should identify, whether it is a left parent or right parent or what. that we should identify. For that, what we are doing is token is equal to get token of symbol. You can see token is a variable of type precedence. So precedence can take what value? It can take all these things, either left parent or right parent, okay, or plus or minus, okay, etc. All these things it can take. So whatever the character, whether it is, so any one of these will be the incoming character, right? Either it will be a some operator like plus, minus, or open bracket or close bracket, or some operand. So if it is an operand also, you can store as operand in token, okay. So we want to identify, for that we are passing that symbol to the function get token, okay. So get token function here I simplified. It's not a complex function. You can easily understand. So there's the get token function. It takes one character yes. It checks what is that character. Whether is it a open bracket. If it's an open bracket, it just returns L parent. If it is a closed bracket, it returns R parent. If it is plus, it returns plus. So on and so forth. If it is backslash 0, it returns EOS. Default, it returns operand. For anything else, it will return operand. Okay. So other than this, what an infix expression may have, it may have a, or it may have one, some numbers may have. All these things it will return as operand. Okay. So now we will get here what is that, whether it is a operand or a L parent or right parent, that will be available in token. Then we check according to our logic. If so, first token we got. If the first token is an operand, then we just push that into the, then we just display that in the monitor. Printf percentage c symbol, whatever the symbol, that operand token you cannot display because token is a variable of type precedence, okay. That is, if you display you will get some undisplayable character, okay. So what we want is the symbol, that whatever the symbol, if it is a, it will display a, okay. So this is the case for operand. Else if it is not an operand, if token is the right parent, whatever the token we encountered, it is right parent, then just pop until you reach left parent. Then just take stack of TOS. Stack is an array. TOS will point to the top of the element. We are not removing here, right? We are directly checking. We are checking whether the top element is open bracket or not. Okay, if it is not a open bracket, we are popping that and displaying that. Okay. Suppose if it is an open bracket, then we pop that and we store it in the some dummy variable ch, which we are not going to use, okay, because that final open bracket we don't want, we want to discard that, so that we are doing like this, okay. The second case. Third case is, if it is an operator, then what should we do? Then while ISP of ISP is in stack precedence of, okay, this is an array, okay, this is an array, but inside this array I am using a function. What function? ISP of get token of stack of TOS. Stack of TOS will return the top element of the stack, okay. That stack element is passed to get token, okay, right. So this get token will return what is the token, whether it is a left parent or right parent or plus or minus, what we will get, okay. ISP of that, okay. So this is, see this whatever enumerated data type contains, it contains number, okay. If it is a left parent, if this get token of, if the top of stack contains, say the top of the stack, sorry, say the top of the stack contains left parent, okay. Let us assume that this top of the stack contains left parent. I don't know why this green color is coming. Say this top of the stack contains uh, left parent, okay. Then get token of left parent will return what? It will return L parent, okay, L parent, L parent. But what is L parent? L parent is nothing but 0. L parent, it will have a numeric value, okay. L parent is nothing but 0. So it means that ISP of 0, that is in stack precedence of 0. What is in stack precedence of 0? You can check there, okay. In the table you can check the in stack precedence, what it will be high or low. The in stack precedence of 0 will be 0, okay. So like that it will take the in stack precedence of whatever the token it is coming, that is compared with the incoming token. Okay, as long as the in stack token is greater than or equal to the incoming token, we pop and display. The moment the in stack token becomes less than the incoming token, we just push the symbol into the stack. So keep doing this until all the characters were, all the tokens were processed. Finally, check is there anything in the what do you call, is there still something is in the stack or not. Okay, so while token equal to pop. Okay, well, so actually here it is not token, here we can use symbol, because token is a variable of type what, precedence. Okay, that will give an integer value, we want a character, while symbol is equal to pop. So you keep popping and check whether is it not equal to, not UOS, whether it is not equal to backslash 0. Okay, keep popping until the popped element is not equal to backslash 0, just display that until it, because at last we pushed null character. Okay, so until you don't get a null character, keep displaying. Okay, finally display a backslash. Let us execute this and see. So gcc inf underscore pstfx dot c dot slash infx underscore, that is infix to postfix. Say I'm giving a string a plus b star c. Okay, it's giving a b c star plus, it's correct. Okay, let me execute, let me give some complex string. Okay, so there is one complex string which we discussed last class. I think it is a slash b minus c plus d. Okay, star e minus a star c. Okay, it's giving correctly abc minus d, abc minus d plus slash ea minus star c star. Okay, so this is the logic to convert an infix expression to a postfix expression. Fine, so go through this program, try this. Okay, thank you, let us stop.